Hello, my name is Kovalchuk, and I will be presenting to you a research paper called Introducing OmniGEC, a silver multilingual dataset for grammatical error correction prepared by me, Mariana Romanyshyn, and Petro Ivaniuk. First and foremost, we want to express gratitude to Apps UCU for computing resources and OpenAI API access. We express our gratitude to the volunteers, students, and lecturers of the National Technical University Kharkiv Polytechnic Institute, who joined and promoted our annotation project. We thank Alexander Skuzhansky, applied research scientist at Grammarly, and other reviewers of the study for their invaluable input. Speaking about outline, we're going to start from motivation, related work, problem settings, and we are going to discuss approach, being introducing new GC datasets, which we call OmniGEC, dataset quality evaluation, both manual and automated, and LLM fine-tuning experiments. Then we are going to discuss outcomes, limitations, and future work. Speaking about motivation, multilinguality is an increasingly popular topic not only in grammatical error correction, but also in natural language processing. For example, OpenAI's recent models are marketed as more capable models not only because of their bare power in English, but also because of their ability to process low and mid-resource languages. Multilinguality is an apparent trend in new GC papers following the same trend in the LLMs. For instance, Grammarly recently posted a research paper on multilingual GC. NLP for Call workshop hosted two multilingual GC competitions in the last 2 years, being MultiGEC 2025 and MultiGED 2023. Speaking of GC and multilinguality, we can see that English language is far over-researched compared to mid and low-research languages such as Ukrainian, Czech, Icelandic, Estonian in terms of GC, even with recent MultiGEC 25 and MultiGED 2023 competitions. Speaking of related work, English monolingual GC methods like high diversity and ranking can be adapted to other languages. However, other methods like Vector as a ranking model are specifically designed to work with English, making the transition problematic. Multilingual GC is an under-researched area with very few published papers, and approaches like synthetic data generation mentioned in the monolingual GC competition, UNLP 2023 shared task on grammatical error correction for Ukrainian, can be adapted to our case. Multilingual LLMs, open source models like Aya Expanse 8b and Gemma 12b were employed in our study, and proprietary models as GPT-4 Mini and O1 Preview were employed as well for synthetic data generation. Speaking of pre-trained LLMs, Aya Expanse 8b is a more compact and modern model than Aya 101, which performed well in GC and supports 23 languages, including Ukrainian. Geometry 12b, the authors do not explicitly state which languages the model support other than out-of-box support for 25 languages and pre-trained support for over 140 languages. However, it is highly capable multilingual model, including in GC tasks, and yields improved performance from Gemma 2 model. Speaking about datasets, we can see that there is very little amount of datasets in multilingual GC area. First of all, MultiGEC 2025, although being a high-quality compilation of monolingual GC datasets from human annotators and learners, have very little examples. Although it supports 12 of our 11 target languages, and there is a standard English GC datasets such as Silencate, CoNNL12 2014, and Bayer 2019, which are both high quality and high quantity. Speaking about GC competitions, as we mentioned, MultiGEC 2025 and MultiGED 2023 was held in the last 2 years, and basically they include the same data. However, MultiGED 2023 includes the same data but for fewer languages. The method laid out there are outdated and do not know LLMs. And speaking of MultiGEC 2025, authors self-limited to fine-tuning the data to fine-tuning the dataset provided by the authors of the competition without parallel language IT templates or more sophisticated workflows, which resulted in low scores. The UNLP 2023 shared task being monolingual JC datasets for Ukrainian and covering only one language. The methods laid out there are easily adaptable for multilingual setting. Speaking about metrics, we employed the following metrics such as edit distance, which is a fewest edits to match the reference text, character error rate, which is a normalized version of edit distance, f.5 score, which weighs precision twice much as recall, errant methods to extract precision recall and f.5 score in GC, and glow score, which is a variation which serves the same purpose as errant, however is n-gram based. Speaking about problem setting, we identified the following gaps: data collection, data composition, and low solution performance. Speaking about data collection, high quality GC data is scarce and multilingual data is not uniform. Speaking about data composition, there is a lack of both data quality versus data quantity ablation studies and cross-language ablation studies. Speaking about low solution performance, the result of MultiGC 2025 do not beat SOTA for individual languages. Speaking about addressing the gaps, we have published new GC datasets, which were collected in a uniform multilingual fashion. We automatically collected silver GC annotations, and we assessed data quality with manual and automatic evaluation methods. As a data composition challenge gap, we propose to cover with conducting ablation studies on both per language basis and data quality versus data quantity. Speaking about low solution performance, we have utilized techniques from English GC, applied fine-tuning to open source language models of different sizes, collected preference data for Ukrainian as a case study for TPO fine-tuning, and adapted methods and techniques that worked well in English GC. Speaking about new silver GC datasets, which we call OmniGEC, consist from following subcorpora: Wiki-Edits multi-GEC, Reddit multi-GEC, and UberText GEC. They are all different in their size and the manner they were annotated. For example, Wiki-Edits multi-GEC was annotated by Wikipedia contributors, and Reddit multi-GEC and UberText GEC were GPT annotated. Wiki-Edits multi-GEC and Reddit multi-GEC comes in 11 languages, and UberText GEC supports only Ukrainian. However, it is higher in size than other two datasets. Speak about synthetic data generation method we employed for labeling the data. This method is based on a SOTA English technique called high diversity and ranking, and is a slight variation of it. The idea is following: we want to generate multiple possible corrections over a single input unlabeled text. And then with a second shot of LLM, we want to aggregate those possible corrections into one more holistic and complete correction. We are going to do so by developing an instruction in English and translating it in downstream languages with DeepL. Then we are going to select examples from Golden GC datasets with O1 preview model, and the latter will be used to generate a few short prompts to generate with GPT-4 Mini multiple possible corrections. Under callout 2, we take unlabeled data, we generate multiple possible corrections with GPT-4 Mini, and then with the power of translated aggregation prompts, we are aggregating those multiple possible corrections into one more holistic correction and complete. Speaking of quality evaluation, we employed both automated and human evaluation methods. Automated evaluation is limited, but it is scalable, and human evaluation is more accurate and representative, but it is a low scale and expensive. We conducted this evaluation only in Ukrainian on a subset of 1,500 samples per corpus. Speak about evaluation results, they are following. For Wikidata's multi-GEC, we yielded the highest GLOW score, but the lowest F.5 score, with varied multi-GEC yielding the highest F.5 score, but the lowest GLOW score. We suppose that difference is due to the number of edits in each corpus. Speaking of human evaluation, we employed 15 annotators and 4,500 data samples and 100 double annotated samples for calibration. Speaking about quality grades, they range from 1 to 5. 1 having new errors in corrected text, 2 having major errors in corrected text, 3 having being a significant improvement over the original text, 4 being grammatically correct, and 5 being both grammatically correct and fluent. As we can see, 70% of synthetic samples are scored as 4 or 5 by human annotators. Here is an example of fluency grade correction and more than original correction, when where original meaning has been changed by the LLM. Speaking about LLM fine-tuning setup, we use zero-shot prompting with IA23 8B to develop the instruction templates. The instruction tune IA expands 8B and geometry 12B with those templates in 3 incremental setup: multi-GEC, multi-GEC plus wiki edits, and multi-GEC plus wiki edits plus Reddit. We measure how additional language and aligned corpora translate into performance in multilingual GEC with GLOW score. As you can see from fine-tuning results, geometry 12B IT having been trained on multi-GEC plus wiki dataset yielded the highest GLOW mean, minimal, and fluency scores across all languages. However, the scores within individual languages may oscillate in GLOW score. However, in general, more language aligned corpora yields in higher GLOW scores. Speaking of deliverables, we have published new GEC datasets on Hugging Face for all our corpora, and we collected new preference data for the Ukrainian part of OmniGEC dataset and published them on Hugging Face. And we published the code repository for data collection and processing on GitHub. Next, the best models, a new SOTA paragraph editing multilingual GEC models were published on Hugging Face, both in 12B and 8B options for minimal and fluency edits. The code repository for instruction tuning with LoRa is openly published on GitHub, and a supplementary research paper has been accepted to UNLP 2025. Speak about conclusions and address gaps. We have addressed data collection challenges with publishing new GEC datasets. We have addressed low solution performance gap with utilizing techniques from English GEC. However, speaking of gaps to be addressed, data composition challenge has to be addressed with conducting evaluation studies in future work. Speaking about limitations, OmniGEC covers only 11 languages. Human annotators annotation was only collected for Ukrainian language, and we use proprietary models for synthetic data generation, which may impact the reproducibility. And due to time and resource limitations, Geometry 12B was only trained on one epoch in multi-GEC, Wikidata plus Redis scenario, limiting our research to 2 open-source multilingual LLMs. Speaking of future work, we want to conduct human evaluation for the new datasets in more target languages, DPO fine-tune model for more target languages as well, and explore full fine-tuning. Thanks for your attention. Bye.